Hello students. In my last slides, I had explained about the pressure belt system on the surface of the earth. Today we will be discussing about the wind. First, what is actually a wind? Very simply, if you have to define wind is actually the horizontal movement of air. When the air moves in an horizontal manner, it can be termed as wind. Basically, wind always moves from areas of high pressure to areas of low pressure. Areas of high pressure to areas of low pressure. When the wind moves in a vertical manner, if it moves in a vertical manner, then we don't use the term as wind, then we call it as air current. If wind moves in a vertical manner, then we use the term air current. If the wind is moving in upward manner, then we actually call it as updraft. And if it is coming down, then we call it as downdraft. Now, before going into the winds, you actually need to know some other things. One is, of course, that is Coriolis force, and the second one is, of course, the Farrell's law. Actually, the wind always moves from areas of high pressure to the areas of low pressure. It will always move from areas of high pressure to the areas of low pressure. For example, in the northern hemisphere, wind is moving, this is high pressure, this is low pressure. Wind is moving from this high pressure area to the low pressure area. Similarly, if it is moving in this direction, high pressure to the low pressure. In the southern hemisphere, it will also move from high pressure to the low pressure, and here also from the high pressure to the low pressure. But while moving, it actually, due to the rotation of the earth, it deflects towards right in the northern hemisphere and towards left in the southern hemisphere. For example, this is high to low pressure, it will deflect or move towards right like this. If it is moving from high to low in the northern hemisphere, it will deflect towards right. Similarly, while moving in the southern hemisphere, it will deflect towards left. High pressure to low pressure, it is deflect towards the left. So basically, this was actually put forward in 1835, first by Gaspard Gustave de Coriolis. He was basically a Frenchman. He had put forward this theory that due to the rotation of the earth, any moving object will actually deflect towards right in northern hemisphere and towards left in southern hemisphere. It was 20 years after him, in 1855, it was explained in total, particularly by W.G. Farrell, as the wind and the ocean current in the northern hemisphere deflects towards right in the northern hemisphere and towards left in the southern hemisphere. And he had explained it with the help of a globe, taking the help of a globe. So based on that, we actually call it the deflection of the wind towards right in northern hemisphere and towards left in the southern hemisphere as the Farrell's law. This deflection is also popularly known as the Coriolis force also. It is also known as the Coriolis force also. But in geography, more commonly we use the term as Farrell's law. Now, the winds, another theory that is there. This theory actually was an interesting observation that was made in 1857 by a Dutch climatologist by the name of Buys Ballot. By the name of Buys Ballot. What he had said a very interesting thing. If a person, suppose if a person stands with his back in the northern hemisphere, if the wind is coming towards his back, then on the right hand side there will be high pressure, and towards the left hand side there will be low pressure. I am again repeating. If a person stands with his back to the wind in the northern hemisphere, if the wind is coming towards his back, then on his right hand side there will be high pressure, and on his left hand side there will be low pressure, and vice versa in the southern hemisphere. That is exactly opposite. In southern hemisphere, if the wind is coming towards his back, then right hand side will have low pressure and left hand side will have high pressure. Now this was actually a very interesting observation. This observation was particularly helpful to the sailors who, just by observing this, they could avoid the storms in the open sea areas. Now one more thing I would like to point out, in your book, the book that is board book that has been given, in some of the books, particularly the new books, this concept actually has been mentioned in a wrong way. It has been mentioned, if a person faces the wind, if he faces the wind in northern hemisphere, it has been mentioned particularly faces. If he faces the wind in the northern hemisphere, then the high pressure actually should be in the left hand side and low pressure should be in the right hand side. Actually that correction should be, wind should be coming from the back, then everything is alright in the whatever is given. Only this word, this faces, if the wind is coming from the back, then it will be correct. Now coming to the winds that are there. Now on the surface of the earth, different kind of winds that blow. There basically the winds can be divided into 4 different categories. One is planetary winds. Second one is of course periodic winds. Third one, local winds. And the fourth one, variable, or also sometimes called as irregular. Irregular winds. Today in this video we will be discussing the planetary winds only. Now what is actually the planetary winds? On the surface of the earth, the pressure belt system that is there, which we had discussed in the last slides, the surface of the earth actually has been divided into 7 pressure belts, that is equatorial low pressure belt, subtropical high pressure belt in both the hemisphere, subpolar low pressure belt again in both hemisphere, and north and south polar high pressure belt. Now planetary winds actually are the winds which blow from areas of high pressure to the areas of low pressure, that is they blow from high pressure belts towards the low pressure belts. Such type of winds we actually call it as the planetary winds. I am again repeating, planetary winds are the winds which blow from areas of high pressure belts towards the low pressure belts in both hemispheres are actually called the planetary winds. Now planetary winds are of 3 types, that is, one is trade winds, second one is westerlies, and the third one is polar winds. Planetary winds, again I am repeating, are of 3 types: trade winds, westerlies and polar winds. Planetary winds are the winds which blows from areas of high pressure towards the areas of low pressure in all the hemisphere. Now we'll move to the trade winds. Now trade winds actually are the winds which blows from subtropical high pressure belt in both hemisphere towards the equatorial low pressure belt. The wind that blows from 5 degree to 25 degree north and south subtropical high pressure belt towards the equatorial low pressure belt actually is known as the trade winds. That is, this is subtropical high pressure belt, the wind blowing towards equator. Here is also subtropical high pressure belt, it is blowing towards equator. These winds we actually call it the trade winds. But while blowing in the northern hemisphere, on account of the Farrell's law, this wind, instead of blowing straight, it gets deflected towards right. And in the southern hemisphere, according to the Farrell's law, it gets deflected towards left. As such, in the northern hemisphere, these winds come from northeast direction, so they are called northeast trade winds. Similarly, in southern hemisphere, as they are deflected towards left, they come from southeast direction. That's why they are called as southeast trade wind. Now, coming to the second one, westerlies. Westerlies, the winds which blows from subtropical high pressure belt towards the subpolar low pressure belt in both the hemisphere are known as the westerlies. Basically, they are called westerlies because they are blowing from the western side. Now here also, on account of the Farrell's law, the winds actually deflect towards right in northern hemisphere like this and towards left in southern hemisphere. As they come from northwest direction, so they are known as southwest direction, they are known as southwest westerlies in northern hemisphere, and in the southern hemisphere they are known as northwest westerlies. The last polar winds, the winds which blow from north polar high pressure belt and south polar high pressure belt towards the subpolar low pressure belts, these winds are called the polar winds. The polar winds, again, on account of the Farrell's law, they deflect towards right in northern hemisphere and come from this direction, as such are known as northeast polar wind, and in southern hemisphere, as they come from southeast direction, they are known as southeast polar winds. I hope you are clear. Again, just a fast repetition of the same thing. Planetary winds are the winds which blows from areas of high pressure belts towards the low pressure belt. Trade winds are the winds which blow from subtropical high pressure belt towards the equatorial low pressure belt in both the hemisphere. They normally blow from 5 degree to 25 degree north and south. This one, westerlies, these are the winds which blows from subtropical high pressure belt towards the subpolar low pressure belt. Normally between 35 to 60 degree they normally blow. And polar winds from the north and south polar high pressure areas, they blow towards the subpolar low pressure belt. They are called polar winds. In the northern hemisphere they come from northeast direction, that's why they become northeast polar wind. In the southern hemisphere they come from southeast direction, that's why they become southeast polar winds. Now they normally blow between 70 degree to 80 degree north and south latitudes. Now coming to some of the characteristics or features of these winds. We'll start with the trade winds. Now trade winds, actually as they come normally from the east, they actually bring rainfall towards the eastern margin of the continents. In fact, the trade winds in the northern hemisphere, their speed is about 16 kilometers per hour, but in southern hemisphere their speed is slightly more. They normally flow between 22 to 30 kilometer per hour. The speed is actually low in the northern hemisphere because of the presence of the land masses, but in southern hemisphere most of the areas are covered by the water bodies. That's why their speed is slightly more. Same is the case with the westerlies also. Westerlies, these winds actually move. In the northern hemisphere, their speed is variable because of the presence of the land masses. But in southern hemisphere, here, as it is mostly covered by the water bodies, they actually blow with terrific speed in areas of southern hemisphere. In fact, normally in the 40-degree south latitude, these winds, as it blows with terrific speed and often make roaring sound, that's why they are known as roaring 40s in areas of southern hemisphere. Similarly, along 50-degree south latitude, they are known as furious 50s. Similarly, along 60-degree south latitude, these winds are known as screaming or sometimes also called screeching 60s. The polar winds, they actually are more stronger normally during the winter months compared to the summer months. But in any case, the polar areas, as they remain cold throughout the year, summer season is actually very little. So they are in summer season, they are actually much more, they have much lower speed compared to the winter months. Now one more thing about the trade winds. Trade winds, I will show you with the help of a world map. Now trade winds, this is actually the equatorial line, this is 0 degree and this is actually the 30 degree. Now trade winds actually are the winds which blow in this direction. Now due to these winds, they bring rainfall along the eastern margin of the continents. They bring rainfall along the eastern margin of the continents. Here also, this is 30 degree, they are moving this side. They bring rainfall along the eastern margin. Because along the eastern margin of the continents, they come from what we call sea towards the land, or basically they are onshore, coming from sea towards the land. So they bring moisture and cause rainfall along the eastern margin of the continents. But the same winds, when they are blowing along the western side of the continents like this, they are actually what we call offshore. Here they are moving in this direction. They are moving in this direction. So basically they are what we call offshore winds. Here also in the southern side also they will be moving like this side. They are offshore here in this side. So you would find along the western margin of the continents, as they don't bring rainfall, many famous deserts of the world have actually formed along these sides. Like for example, here there is Sahara Desert. In this portion there is of course Kalahari Desert. Here there is Atacama Desert. Here there is Sonoran Desert. Here of course the Great Australian Desert is there. So eastern margin of the continents get rainfall, but western margin of the continents hardly gets any rainfall. Similarly, in case of the westerlies, they blow from 30 degree to 60 degree. They bring rainfall along the western margin of the continents. They bring rainfall particularly along these western areas. But if you remember in the slides, last portion of the slides, I had explained shifting of the pressure belts. The pressure belt system that is there on the surface of the earth, they actually shift towards north during summer solstice and towards south during winter solstice. So what happens is that when the pressure belt actually shifts towards the north during, say this is the 0 degree, it will shift towards 5 degree north during summer solstice. This portion will shift. As the pressure belt shifts, so westerlies during the summer months do not cause any rainfall. But when in the winter months, as they move southward, they actually cause rainfall in many areas, particularly these areas of Europe. During summer months, they basically become what we call offshore, but during winter months they basically become onshore and cause rainfall. Well, that was all about the planetary wind system on the surface of the earth. In our next next class we will be discussing all the other types of wind. I hope you all have got a clear idea about how the wind actually blows, and do go through the book to have a better idea how the wind actually blows. Try to understand the concepts clearly, because if you don't understand, the same thing will come across again in class 10. So it's better you know how the wind actually blows. And of course, this diagram of pressure belts and planetary winds is actually very important. You need to practice this diagram again and again. Thank you all.